So good morning to all of you. So today's the topic will be renewable energy resources, that is the fresh unit that will be starting today. This is the very basic unit and it will be very good for you in the exam, from the exam point of view, because it will not be having any kind of numericals in it. It will be a complete theory unit and it will be highly required because this will going to give you the basics of renewable energy resources, that how renewable energy resources used to behave in the particular national grid, and how it is being used, why it is being used, what are all the benefits in it. So we will be covering this unit in, you can say, in 2 or 3 videos. So starting with this fresh unit, that is renewable energy resources, going to the content. The contents that will be the whole lesson planning that you can say is being included over here. According to the lesson planning of renewable energy resources, you will be having these much points. That's it. That is introduction, distributed generation through renewable energy, bulk power generation through renewable energy. It's solar power. We have to discuss the basics of solar power, its issues and concerns, and we have to also discuss the wind power and its issues and concern. In this lecture, we will be discussing only the introduction and distributed generation through renewable energy. And in the further more videos, we will be discussing over the next subsequent points. Okay. So, but I am making it more clear that this unit is the basic unit. We will be discussing very much basic about renewable energy, because in your coming semester, if you are choosing or opting the renewable energy resources, that will be the elective course, will be very good for you if you are knowing some of the basics of renewable energy, because this subject will going to come as an elective course in your further semesters. So for this only, this unit is being included in this fresh subject of FPS. This was not there, this unit you can say was not there in your senior syllabus. So it is a good unit where you will be getting some of the basics of renewable energy. Going ahead, first of all, we will be discussing the numerical, or you can say the number data of, you can say, of a particular renewable energy. As you can see from the, simply from a diagrammatic view or a pictorial view, that we want energy not from coal, we want energy not from nuclear, we want energy not from hydro, but we want energy from solar, we want energy from wind, we want energy from biomass. Why? And etc. Why? Because these resources are free. Main basic point of using renewable energy is that resources that will be using in solar, in wind, in biomass will be always and always, it will be completely free. So we can use as much as we can want, but as it is giving a big advantage of not having any capital cost in the resource, but it will not be available readily. What I want to say, that I mean to say that it will not be available readily means that it will not be available across 24 hours. Wind will be available across 24 hours, but solar will not be available across 24 hours. It will be available around 13 to 14 hours only, depending upon the particular latitudes and longitudes. But utilizing that 13-14 hours, utilizing that amount of hour, that amount of time in which we are getting the maximum solar irradiation or maximum wind power, that is the job of an particular geographical engineer and particular electrical engineer, where he or she will be determining that whether to hoist our particular power plants where we'll be getting the maximum irradiation, or where we'll be getting the maximum wind pressure, if we are considering wind power as a renewable energy. So according to the data available from the report of International Energy Agency, it has been seen in the past few years that the generation through renewable energy resources is being increasing continuously, and now it is been expected that by this year, that is 2020, it will going to reach about 26 to 30% of the total amount of generation, and that is the report of International Energy Agency. So I am not talking about our country, I am talking about the world. In the world, the total amount of generation through renewable energy will going to be increased by or it will be increased to 26 to 30% of the total amount of generation that we are doing. So it has been written over here that more clearly needs to be done, though for the reasons stated below, but these figures are encouraging from the perspective of the use of renewables on its own. Most long-term forecast models predict that use will triple between 2012 to 2040. That it has been also predicted that in the year in between 2012 to 2040, and we are now reached till 2020, this generation through renewable energy sources will going to triple, that it will going to increase triple fold. Okay, so it will be a very, you can say, trending topic nowadays going on about the renewable energy resources. And you are also knowing about the subject or topic that is trending today in a modern scenario, that is electric vehicles. So electric vehicles, if you want to study renewable energy resources, both these sources or both these subjects or both these topics or both these contents are very very much important in a particular today's modern scenario. First that we have to discuss, the basic that we have to discuss is the distributed generation through renewable energy. Just read this, what is written in the particular slide, that distributed generation is an approach that employs small scale technologies to produce electricity close to the end users of power. DG, I am writing over here DG is nothing but distributed generation only. Its technologies often consist of modular, that is sometimes it can be of renewable energy, it can use some central power plants, also small power plants or small hydropower plant, or also can be utilized over here in place of renewable energy also. But we will be considering this distributed generation only through renewable energy in generators, and they offer a number of potential benefits. In many cases, distributed generators can provide lower cost of electricity, higher power reliability and security, with fewer environmental consequences that can traditional power we can achieve through traditional power generators. You already know that the maximum power generation coming to our home or to our industry is due to only thermal based power systems. In thermal, in India we are going towards the coal based power systems. The maximum generation is being carried out through these power plants only. But now we have to shift from those central generations to distributed generations. In distributed generation, what is written over here, that it will going to employ a small scale technology to produce electricity close to the end users. Always we are talking in the classes also that the central power plants are located very very far from the particular user end or from the particular load source. But here what we are talking, that in distributed generation, the generator or any type of means we are using for generating electricity will be very much closer to the end users of the power. That is the most important point of this distributed generation, that the generator will be located very much nearer to the end user of a power, and that will going to employ a small scale technology. And we can say that it will not be generating much, but it will be generating very small for a small area. So that area will, you can say, will be isolated, and it will be solely depending on that particular distributed generation too, and it will be getting from the national grid power also, from the national grid. And this distributed generation that you are planting, that will be employing on a small scale, can also feed power in the grid, as well. So it will be serving two purposes, that it will be also satisfying the load of your particular closer end, and it is also supporting the grid also. So it will be having two benefits of using distributed generation. Okay, going much deeper into it, we can again go, what is written in this slide is that the current model for electricity generation distribution is dominated by centralized power plants, that we have already talked, that we are solely depending upon the centralized power plants. Centralized power plants में क्या क्या आते हैं? What we are having in the centralized power plants, we are having coal, we are having oil, or we are having natural resources. But these resources, again I am talking, but these resources are not free. We have to extract it out from the particular earth. You can say that coal is available in the inside the earth, oil is also natural gases are also natural, that are also free, but the extraction of these particular resources is very costly. We have to first extract it out. Your coal will not be available in your general merchant store. You have to go, you have to dig, you have to go inside you have to dig inside the earth, and then you have to use big machines to extract that coal from outside from the particular earth. So that will going to cost you much. But in the perspective of solar and wind and biomass that are readily available, in which you do not have to extract it out something, just you have to use certain panels and you have to use that solar radiation which is available at your nearest end. Okay, that is the much bigger difference between the resources used by the centralized power plant and the resources used by the renewable energy. Okay, again going ahead in this, current substation anywhere can be anywhere from tens to hundreds of miles away from the actual users of power generated. This requires transmission across the distance. So what is this means that if you are using centralized power station, you will be requiring high number of substation that will be very much far enough from the user end. So transmission line cost will be also included. The development of substations or substation buildings and its wires and its equipment will also include or will also going to increase the cost. But if you are having your generator, if you are having your generation very much closer to your end very much closer to your user, then it will not going to increase the cost much as compared to centralized power plants. Okay, that is the much difference that I want to say is written over here. Going ahead, the system of centralized power plants has many disadvantages. Now what we are discussing over here, we want to discuss some of the disadvantages and benefits, and you can say potential benefits of distributed generation. First of all, what is written over here, the system of centralized power plants has many disadvantages. What are disadvantages? As your substation, as your power plant is very much far enough from the user end, so it will going to increase or it will going to add transmission distance issues. Transmission distance issues means if you are having long length cables, long length overhead lines, it will going to have certain amount of wind pressure on it, it will going to have a fault on it, it will going to increase the cost. Heat will be there, wind will be there, wind pressure will be there, ice loading will be there in your higher areas, in your hilly areas, you can say. That all problems, that all issues will be included in transmission distance. These systems contribute to greenhouse gas emission. As centralized power station will be mostly in thermal based power plant, you will be using coal based. So if you are burning a coal, it will be increasing out, it will be releasing out very much high amount of heat. So global warming will be there. As global warming will be there, so greenhouse gas or greenhouse gas emission will going to come into picture. As greenhouse gas emission will going to come into picture, the whole earth will going to warm, and global warming will be the result in the final work. So you can read from here that greenhouse gas emission, the production of nuclear waste, inefficiencies and power loss over the lengthy transmission lines, and environmental distribution where the power lines are constructed, and security related issues. So if you are designing any amount of power lines in a particular area, you will be capturing that area, you will be buying that area. So if that area is agricultural land, you are employing or you are using some of the area of your agricultural land, so it will be again affecting the environmental distribution. It will be also affecting the wildlife, because many you can say if there is any amount of short circuit happens, and if there is high amount of current is flowing, and that is attracted or interacted by the particular flies, so it can affect that wildlife also. As power lines are very much lengthier, it is having high length, it is having long lengths. As it is having long lengths, so what we can say, the cost will also going to increase for the, you can say, in the case of material. Okay, and if you are having that much amount of long length lines, if you are having that much amount of equipments, high cost equipments, so there will be certain security related issues also available in a particular country. Okay, the next point, many of these issues can be mediated through distributed energies. These issues can be mediated, or you can say can be eliminated through these distributed energies or through this distributed generation concept that we are discussing in this particular video. By locating the source nearer or at the end user location, the transmission line issues are rendered obsolete. what is written over here, if you are locating the source is nothing but the renewable energy resources or distributed generators or generation that you are using, it is nearer or at the end user location, all the transmission line issues that we have discussed in the previous paragraph will be rendered obsolete or will be completely eliminated, will be rendered obsolete or it will be completely eliminated. Distributed generation is often produced by small modular energy conversion units like solar panels. So here there is only one example written over here, that distributed generation is often produced by smaller modular energies. It can be a very small energy point of view, we can consider it to be a solar panel. We can use solar panel and we can use solar irradiation and we can generate electricity. Okay, in that also we can have small wind turbine, and we can again generate wind power through wind pressure or through wind, using wind if it is having a particular amount of pressure available in it. Okay, here in two figures or two pictorial views you can see that previously what we are using, classic electricity paradigm, means in the left hand side that is nothing but the central power station that we'll be using. Your central power station will be shifted, will be located very much far from the user end, and you will be getting supply from there only. But now what we are using, we are using distributed on-site generations. What we are using distributed generations, on-site generation, that will be also dealt, or that will be also termed as smart grids, or that will be also termed as microgrids. Okay, so the concept of microgrid, concept of smart grid, concept of distributed generation is that concept only in which you will be using renewable energy resources, and those localized resources will be placed very much nearer to the source end, nearer to the end user, nearer to the end users, so that all transmission line issues, security related issues will be completely rendered obsolete, or it will be completely eliminated. Okay, this is known as paradigm shift from yesterday to tomorrow. We are using that centralized power station. Now what we are planning, we are shifting towards the distributed generators, so that it will going to increase the reliability also, it will be increase the security, it will be it will going to decrease the security concerns also. Okay, now what we are discussing, we will be going to discuss the potential benefits of DG. These are the very much important points, and I'm again repeating this, that this presentation is very much important. The points written over here, that you have to study only these points only. You do not have to refer any amount of data from any other resources. You just study this, remember this, understand the concept, and write the answers. It is much satisfactory PPT that I have made, that will going to complete this unit very satisfactorily. You do not have to use any amount of other resources for this particular unit. Okay, again coming back to our point, that is potential benefits of direct distributed generation. The first point, distributed resources can improve the efficiency of providing electric power. That we have already discussed, that all the transmission line issues will going to reduce, and hence the efficiency will going to increase. What is written over here, that transmission of electricity from a power plant to a typical user waste roughly to 4.2 to 8.9% of electricity as a consequence of aging transmission equipment. You can see that if you are using a power plant, centralized power plant, so there will be a decrement of, you can say there can be an increment of reducing or aging of your transmission line equipment from 4.2 to 8.9% due to its inconsistency, due to its some reliability concerns also, or due to growing congestions. But if you are using distributed generation, all the equipments will not be required that of high much quantity, because your source will be very much nearer to your end user, so these all losses will going to wiped off. Okay, the next point, the consumer electricity bills include the cost of vast transmission grid. The use on on-site power equipment can conceivably provide consumers with affordable power at a higher level of quality. If you are if you are using your distributed generators, the customers electricity bills will also going to be decreased, because your customer bills are also including the transmission line wires cost, transmission line conductors cost, that will be completely eliminated if you are using distributed generation, and it will going to provide affordable power with higher level of quality. Other points, that DG technologies may provide benefits in the form of more reliable power for industries that require uninterrupted service. If your source is very much near to your end consumers, so the point of discussion of uninterrupting in the power supply will going to be drastically reduced. Okay, DG can contribute to different transmission upgrades and expansions. DG can also contribute to expansion. The expanding a particular centralized power plant is very much tough, and high number of trail of papers has to be worked in from government point of view, and then you can think of, you will be having high number of concerns in expanding your particular centralized power station, but distributed generations can be easily expanded. Okay, DG technologies may improve the security of a grid. Again, the security of the grid will be also very much be improved if you are using distributed generation, because your source is also very much nearer to your end consumer. So you are working on a very small periphery, so again the security of the grid will going to increase. In decentralized power generation help reduce the terrorist targets also, because mostly if you are talking about the terrorist targets, they will be targeting the nuclear power plants, or that they will be targeting the coal based power plants to you can say to hit the economy of a particular country, so that your all the generation will be stopped and your all the work will be hit, you will be interrupted. So if you are having decentralized, or you can say distributed generation, in that the issue of terrorist targets will also be decreased very huge, in a huge form, you can say. This is nothing but the discussion that we have done in the potential benefits of distributed generation. That is nothing but the matrix wise benefit, where you can easily study this by just looking this, and you can write your answers, because here that red tick mark showing that these points are easily available in distributed generations, and where the ticks are not there, that is not possible through distributed energy solution. That is only in the emergency power supply. If you want to increase the power supply in an you can say for the huge power peak demand, you cannot use distributed generator, because it will be limited for a limited amount of demand. For there you have to be dependent on the centralized power station. So we are here not talking about that we will be shutting down our centralized power station. That is our मेन बेसिक्स, दैट इज़ आवर यू कैन से, वो हमारी नींव है, हम उसको नहीं चेंज कर सकते, बट वी कैन थिंक ऑफ यूजिंग और मोर moving towards the distributed generation, because we always know that due to global warming, due to greenhouse effect, or due to greenhouse gas emissions, the temperature of the earth is continuously increasing. So to control that, to control the pollution, to decrease the carbon credits, we are moving towards the renewable energy, and in that we will be using distributed generations. Okay, the most and the last topic that we want to discuss, that I want to discuss in this particular video, is the basics of islanding. That is very much important concept, and that if you are going to take renewable energy resources, the islanding will going to come into picture, and many projects and many things you can do in a particular islanding. But here I will be just giving you the very basic meaning of islanding, so that each electrical engineer should know that what is this islanding. So what is written over here? Islanding is the condition in which distributed generator continues to power a location even though electrical grid power is no longer present. Islanding can be dangerous to utility workers who may not realize that a circuit is still powered, and it may prevent automatic reconnection of devices. Additionally, without strict frequency control, the balance between load and generation in the islanded circuit is going to be violated, leading to abnormal frequency and voltages. What is meant by this? If let's suppose in a particular national grid, the power is shutted off, or power is being you can say there is no power available in a particular electric grid from the centralized power plants due to some fault, but your distributed generators, your renewable energy sources will be continuously feeding the power, as it will be continuously feeding the power, so it will going to make a island of a power that is not traveling through the particular generating grid, because grid is not having a power. Grid voltage is dipped equal to, or you can say that the grid voltage is reduced to zero. As it voltage is reduced to zero, so you can say that now your distributed generators cannot work easily. So for that, this process is known as islanding, where your other main grid power is no longer present, but still your DGs are working. It is continuously feeding. As it is continuously feeding, so it will not going to feed at that particular amount of frequency which should be available in a particular grid, which is not available now, because if you are generating from solar, you are generating DC power supply. That changing DC will be converted to AC through inverter, but that inverter will be designed in that manner that it will going to match the value of frequency and value of voltage as present in the particular national grid. But let's suppose that if national grid power is no longer present, that amount of voltage will not be matched, and it will be only continuously increasing the power, and it will going to make that island. As you can think of island, which is made inside in a particular sea, surrounding the whole area of the island is surrounded by the water, but in the center island will be built, which is of no use. That will going to cause a abnormal condition. Okay, so there should be certain methods available which should detect this islanding, and anti-islanding effect should be there that can also disconnect to distributed generators too when this type of problem occurs, when there is no power available in the electrical grid. Okay, this much will be keeping in this particular video, in which we have discussed about the distributed generators through renewable energy, the introductions of renewable energy, the very basics of renewable energy, and very much basics of a islanding effect. Okay, thank you.